Okay, so now we're going to learn about magnetic fields, and we have a couple pictures here of some dramatic examples. Here we have a giant electromagnet being used to pick up large amounts of scrap metal, and here we have a tokamak, which is used to contain extremely high temperature plasmas, much higher than any temperature that we can hold with an actual material object. And we're going to explore how magnetic fields let us do these things. This chapter will focus on the behavior of charges in magnetic fields and what magnetic fields do. The next chapter will focus on what sorts of things create magnetic fields, how we make them. So first, let's just look at a brief review of magnets. You've probably had some experience seeing a bar magnet, a disc magnet, horseshoe magnets. You've probably seen a compass, and you may very well have played with refrigerator magnets that you can write things on the refrigerator. So let's consider for a moment some of the properties of magnets. If you take a magnet, standard magnet, you may have done this before, and you take another one, well, if you bring a certain two ends of them together, they will attract. They'll experience a force towards each other, just like that. However, if we take one of them and turn it around, suddenly, instead of being an attractive force, they repel each other. They'll tend to move away from each other. Okay? So, we see that magnets can both repel and attract. In some orientations, they repel. In other orientations, they attract. So let's look at those behaviors and see whether or not we can say magnetism is a type of gravity. Well, we know gravity always attracts, whereas magnetism sometimes repels. Plus, we know from the fact that we can pick things up with a magnet that magnets, just a relatively small magnet, can exert as much force as the entire Earth does on a small object. So it's much stronger. All right. Also, gravity acts on all objects, whereas magnets only act on other magnets and certain metals. Some metals I can bring up to a magnet. Put an M on this to say it's a magnet. And I bring up another metal, and these two will attract. And then even if I flip one or the other around, they will still attract. Okay, so sometimes we can get magnets that you flip one around and the other side will repel. Sometimes we can get a magnet with just a piece of metal that'll always attract. So, gravity and magnetism are clearly not the same thing. Gravity always attracts, magnetism sometimes repels, is much stronger than gravity, and gravity is involved, affects all objects, whereas magnetism only affects certain objects. Okay, let's compare magnetism and electricity. Remember, we found that electricity showed up only after rubbing, and leaked off. Magnetism can be permanent. Okay, electricity would give some effect on all things. Okay, electricity will attract even neutral objects slightly. Magnetism, as we learned before, only certain objects. And last and perhaps most importantly, what happens if we stick a charge in a magnetic field or near a magnet? So if I have a magnet here and I put a charge, if this charge is sitting still, I don't see any force at all. However, if the charge starts to move, I may see a force. And that's going to be the hallmark of magnetism. Magnetism exerts forces on moving charges. Alright, so clearly magnetism is not just a form of gravity, it's not just a form of electricity. It's some new kind that sometimes comes in permanent magnets, affects certain materials, and does not affect charges that are at rest, but it does exert forces on moving charges.